Happy morning, my dear children. Happy morning. We completed the first volume, almost all the questions. Some of the lessons, a few lessons we marked. A few lessons we are not marked, okay? Especially for the chemical quantities, we have a lot of problems. Solved questions. We should be solved that one. So, I think that the question number 8 and question number 10, question number 10, 11, 12. Today we can resolve this question. Okay. So before that, we have the question number 1. It's a chemical quantities, lesson number 7, chemical quantities, the page number 204. That lesson is over. So we can mark the question solve the book bag question. Page number 230. Page number 230. Answer the following. The previous I told you the one-word question. The one-word question that is given on the book bag side. You should be marked the one-word question. The remaining 2 marks, 3 marks, 5 marks. We shall mark that. Okay. The question number 1 and 2. Page number 230. Page number 230, question number 1 and 2. I will give note, okay? Later I give you. And about the question number 3rd. Derive the integrated rate law for the zero order. A gives product. That's a 5-mark question. Page number 240. Please all of you turn over page number 240. They have the headings. Integrated rate law for the zero order reaction. Middle of the page is having the headings. 214. Okay. That remaining the page is full. Started with integrated rate law for the zero order reaction. And that page last line. A plot of A versus time gives a straight line with a slope of minus k and y intercept of A naught. Up to that much. Then about the question number 4th one. That's a 3-mark question that already we solved that question. Define half-life of a reaction so that for a first order reaction half-life is independent of initial concentration. One of the very important 3-mark question. Page number 215. Page number 215 they are having the heading half-life period of the reaction. That full up to the last T naught is equal to 0.6932 divided by K. Next question. Question number 5. What is the elementary reaction? Give the differences between the order and the molecularity of the reaction. That also we learned thoroughly. That's a 3-mark question. Page number 210. 210. The molecularity heading having. This question having 2 options. One is about what is an elementary reaction, and the second part is about differences between order and the molecularity of the reaction. So 2 options having. First one you should be right the elementary reaction. That the molecularity, that paragraph, 4th line. Please all of you take page number 210. 4th line. Each and every single step in a reaction mechanism is called an elementary reaction. Already we learned thoroughly. And next option, differences between order and molecularity. That is also having the right corner of that page. Define order of the reaction and molecularity of reaction. That also should be marked. Next about question number 6. Explain the rate determining step with an example. This is one of the very important questions. Today this question is an assignment. I explain the rate determining steps with an example. Page number 210. The molecularity. Page number 210. Middle of the page molecularity. I think that the third paragraph. Let us understand the elementary reaction by considering the decomposition of hydrogen peroxide catalyzed by iodine ion. Okay. 2H2O2, that is hydrogen peroxide gives water liquid and oxygen gas up to the next side of that page, after the three equation, that is step 1 equation, step 2 equation, overall reaction, and having one small paragraph. These two reactions are element reaction adding equation 1 and 2 gives overall reaction. Step 1 is the rate determining step, and since it involves both hydrogen peroxide, okay, and iodine ion, the overall reaction is a bimolecular. That's question number 6. This question is today assignment question. Anyhow, question number 7. There is a 2 mark question. Describe the graphical representation of first order reaction. Describe the graphical representation of first order reaction. Page number 213. Okay, please all of you turn over the page number 213. Top of the page, they have a graphical representation. Okay, here starting with here and ends with a plot of land A versus T for the first order reaction. A gives product with the initial concentration of A is equal to 1.00 m and K is equal to 2.5 into 10 to the power minus 2 meaning minus 1. Okay, up to that much. It's a 2 mark question. Next about write the rate law for the following reaction. This is the important question. Okay, please all of you take the note. Please all of you take your note. It's a very important question. The question having two options. Two options having. One is A and another is a B. Okay. Please all of you take a note and write. And also one more question. Explain the effect of catalyst on the reaction rate with an example. That you mark it there, after that we can derive. Okay. Explain the effect of catalyst on reaction rate with an example. Page number 224. 224. They are having effect of presence of a catalyst. That paragraph, third line. Please all of you take the third line. A catalyst is a substance which alters the rate of the reaction without itself undergoing a permanent chemical change. Up to that paragraph full. Okay. Up to that paragraph full. That is about the 9th question. Next about 8th question. Okay. 8th question, 10th question, 11th question and 12th question. Page number 230. 8th question, 10th question, 11th question, 12th question. Okay. We shall write the question. Please all of you take the note. We shall write. Okay. Lesson 7. Lesson 7. Chemical kinetics. Okay. First one. Page number 230. Question number 8. Okay. Question number 8. The question we have is write the rate law for the following reaction. There are two options. One is A reaction that is 3/2 order is X and Z order in Y, and also a reaction that is second order in NO and first order in Br2. First of all, you should write the reaction. The reaction is X plus Y gives product. Okay, X plus Y gives product. You should write the rate law. Rate law is equal to minus of dx by dt is equal to minus of dy by dt. Okay, that is equal to what? Rate. That is equal to rate. Am I right? So that is equal to K into X 2 by 3 Y 0. So if you write rate, what is about the rate? Rate is equal to K into X 2 by 3. This is the answer for the 8th question. For the first option A. Okay, first option A. Next about the second option. The reaction that in second order reaction in NO and the first order in Br2. The reaction in 2NO plus Br2 is 2NO Br. That's a question equation. What's the rate? Rate is equal to K NO, we should be right order, 2 Br2. Okay. This is the 8th question answer. Next we shall write the 10th question answer. Okay, the 10th question is a very important question. Okay, we shall write the 10th question. Very important question. The rate law for a reaction of A, B and C has been found to be rate is equal to Ka square B and L the power 3 by 2. How would the rate of the reaction change when? We have some option. What are the options? First one, concentration of L is quadrupled. Second one, concentration of both A and B are doubled. Third option, concentration of A is half. Fourth option, concentration of A is reduced to 1 by 3 and concentration of L is quadrupled. Okay, this is the condition given. We shall write the steps. What are the steps we have to write? Once again, please all of you read the question. First one, the concentration of L is quadrupled. Okay. I shall write the question. Okay. You also write the question. I am writing only the answer. Book back question. Question number 10. Page number 230. First volume. Okay. Chemical kinetics. Okay. Sir. Sound lesson, chemical kinetics. Question number 10. Okay. First you should be write the rate formula. All of you know. From that equation, from that question, we should be write the rate. What is about the rate? Rate, okay. You write the rate. Rate is equal to K A square B L 3 by 2. Okay. That is the first condition, first one. How would the rate of the reaction change when? First one, the concentration of L is quadrupled. That means by 4 times. It should be multiplied by 4 times. Okay. So about the L, concentration of L. You should be multiplied by 4 times. So L, that's a given. L is equal to 4L. Okay. Then we should be right. We substitute this here. L by 4. Okay. Rate is equal to K A square B, which should be multiplied by 4. Okay. 4L 3 by 2. Clear? First you should be squaring. Okay, squaring on both sides. Squaring on both sides. Squaring. Yeah, squaring on both sides. Okay. That means rate square is equal to here K square A square, again square. We can be right 2 into 2, that is 4. Okay. 4 B square. Here also 4L by 2, am I right? 4L 3 by 2 into square. Okay, square. Here. That we can written as K square A 4 B square 4L 3. Because we can cut this one. Cancelling. Okay, we cancelling. Clear? Then again we can write that is equal to K square A 4 B square 4 3 can be taken 4 3 4 Q and L Q. Clear? That is, we can take this taken as a constant. Okay. Taking here 4. This 4 is taken outside. 4 Q K square A 4 times B square. Already 4 cube we take. Am I right? Then L cube. Bracket. Okay. Then raise square is equal to what is about the 4 cube? 4 cube. 4 into 4 into 4. Okay, 4 4s are 16. Am I right? 16 into 4. So what's the answer? 16 into 4? 4 into 4. 2. 64. Okay. 64 is the answer. So raised square is equal to 64. 64 K square A raised to 4 B square, okay, B square L cube. Okay. Here we should take the square root. Square root on both sides. Okay. You have to take the square root on both sides. taking square root. So the rate is equal to square root of 64. Clear? Square root of 64. Remaining right. K square k. Here taking square root. So k square is converted to k. A raised to 4 is converted to a square. Clear? A square and also b square is converted to b. Am I right? B. B and here also L 3 by 2. Okay. Rate is equal to, this can be written as 8 into 8. Clear? 8 into 8. 8 into 8. Clear? Then K A square B L 3 by 2. Okay? Then the rate is equal to, this commonly we can be taken as 8. Okay, 8 square 8. K A square B L 3 by 2. Okay, this is the what? This is the answer. Okay, previously you write on the question, that is the rate is going to be write on the question. The formula. What's about the rate formula? The first starting beginning we write. Okay, that is what's about the formula? Rate K A square B L 3 by 2. Am I right? This is taken as equation number 1. This is taken as equation number 2. The beginning we wrote rate formula, that is equation 1. Here this is what? Equation number 2. Here when we are comparing equation 1 and 2. Okay, when we are comparing equation 1 and 2, what's the difference between 1 and 2 on comparing? Okay, this is 8 times increases, am I right? Equation 2 is 8 times increases. Comparing equation 1 and equation 2. On comparing equation 1 and 2, what is happening here? The rate is increased by 8 times. Okay? As per our textbook question number 10, the first point, concentration of L is quadrupled. Am I right? So, when we are comparing equation 1 and equation 2, here equation 2, the rate is increased by 8 times. Rate is increased by 8 times. What is about the next one? Concentration of both A and B. Concentration of both A and B are doubled. Okay? Concentration of both A and B are doubled. So what is the answer? Shall we write down? For every time we should be write the rate formula. That will take us 1. Okay, for every time you should be write the rate formula. That equation is taken as equation number 1. Okay. So that is a concentration. The first one is over. The second one, concentration. Concentration of both A and B doubled. Okay, concentration of both A and B doubled. Okay. First of all, you should write the rate equation. What is about the rate equation? Rate equal to K A square B L 3 by 2. This is always taken as equation number 1. What are the given factors? What are the given? The A value, A is equal to 2A and B is equal to 2B. These are the given. Am I right? Given. Substitute these values on equation 1. Substitute this value. Values in equation 1. What's the answer in equation 1? So rate is equal to K into, what's the value of A? A means 2A. Am I right? What's the value of A? A means 2A. K into 2A. Formula having square. And B is about what? 2B. And also having L 3 by 2. 3 by 2. Here. Then rate is equal to, we can be taken as 2 square. Okay. 2 square, if you write the K also, K into 2 square. This 2 square we take. Then about the A square. Okay. Next I am taking 2 B here. Then L 3 by 2. Yeah. Then these 2's are I am taking outside. Rate is equal to 2 into 2. Total all 2's are taking 2 square 2. Okay, 2 into 2. K A square B L 3 by 2. Okay. Then rate 2 into 2 4. 4 into what? 4 into 2 is equal to 8. 8 K A square B L 3 by 2. Okay. Here that is the first topic, that is the concentration of L is quadrupled. Am I right? That here having the 1 and 2 equation is over. So all the time you should be write the equation 1, but second equation is over. So here I am taking what, the equation number 3. Okay, this is equation number 3. So 2 already is over, so I am writing 3. Okay, so we have to compare equation 1 and 3. Equation 1 and 3, we should be compare what is the difference. Okay, here also 8 times increase, the equation 3, 8 times increase. Comparing equation 1 and 3. 1 and 3. Here equation 3 is increased by how much times? 8 times. In equation 3, the rate is increased by 8 times. Okay, when the concentration of both A and B are doubled. Okay, clear? Next we shall write the third one, concentration of A. The third one, concentration of A of, okay, this is the condition. Then here, the question, about the question, concentration of A is half. Okay, that's the question. So if we write the question here, what's the value of A? A means half. So given A is equal to A by 2, that's the given. Am I right? That is half. Am I right? So what's the equation 1? Equation rate is equal to K into A square B L 3 by 2. This is equation number 1. So what's the value of A? A is equal to A by 2. Okay, that's what? That's a given. Substitute this A value in equation 1. A value in equation 1. So what's the value? Rate is equal to K into, what's the value of A? A by 2. So A by 2, here have a square. So A square B L 3 by 2. Okay, 3 by 2. So we can written as K into 1 by 2 the whole square A square B L 3 by 2. Clear? This can be, you can written as like that. Okay. Then that is equal to half square I am taking outside. So half 1 by 2 the whole square K A square B L 3 by 2. Okay. Then here also 2 square. Okay, 1 half 2. 2 to 2 is equal to, can written as 1 by 4. Clear? 1 by 4. K A square B L 3 by 2. Okay, this is equation number what? 4. That is the first one, equation number 2 over. Second, equation 3 over. Here the third we are writing equation number 4. What is about the fourth one? When we are comparing equation 1 and 4. Comparing equation 1 and equation number 4. So what is the difference about equation number 1 and 4? Here the rate is reduced, not increased. The rate is reduced to 1 by 4 times. The rate is reduced by 1 by 4 times. Okay, times. Clear? Then what is about the fourth one? Concentration of A is reduced to 1 by 3 and the concentration of L is quadrupled. Okay, that is 4 times multiplied by 4 times. The fourth one, I'm going to write the fourth one. Concentration of A is reduced. Concentration of A is reduced to 1 by 3. Okay, 1 by 3 and it's the fourth one. And concentration of L is quadrupled. That's the question. So for each and every one you should be write the rate formula. Okay, each and every time you should be write the rate formula. What's the rate formula? Rate is equal to K into A square B L 3 by 2. So here what are the given? What are the given? As per the question, what are the given? Concentration of A is reduced by 1 by 3. A is reduced by 1 by 3. So A is equal to A by 3. And L is quadrupled, that is multiplied by 4. L is equal to 4 into L. So you should be substitute this value in equation 1. Okay. Substitute this value on equation. Equation 1. So what is the answer? Let's substitute this value. Rate is equal to K into, what is the value of A by 3 square. Okay. And about the B, there is no change. And this about L. L is equal to how much? L is equal to how much? 4L. Okay. L is equal to 4L. So 4L as per the formula 3 by 2. Okay. 3 by 2. Here also you should be take the squaring. Okay. The squaring on both sides. Squaring on both sides. Both sides. Squaring. We have square. Then rate square is equal to. Here also you should be square. Okay. K square A by 3. Here square means 2 into 2 4. B. Here also square 4 L 3 by 2. 4L 3 by 2. Okay. Then also we are squaring, we get what is about that? We can be right? Totally 3. Then K square is equal to, here we shall write, not A square. Rate square is equal to K square, we should write 1 by 3, 4, then you write A 4. Okay? Then about the B, no change there, B square. About the 4 cube, L cube. Here. Then rate square is equal to 1 by 3, 4 into 4 cube. Okay, this can be written as like that. 4 square a raised to 4 b square l cube. We should be taking a root on both sides. We are taking the root on both sides, okay? We are taking a root on both sides. Taking a root on both sides. Clear? So how will you take the root? That means rate is equal to 1 by 3 4 into 1 by 2. Like that we can write. Then 4 cube. We can write as 64 1 by 2 k square a square b and L 3 by 2. Okay. Then rate is equal to 1 by 3. 1 by 3 we can be cancelling 2. Like that we can be 64 can be written as 8 into 8. Root of 8 into 8. Then k square a square b L 3 by 2. Clear? Okay. 3 by 2. So here 3 square can be written as 1 by 9. 3 square. Okay. Into 8 into 8. Root of 8 into 8 can be written as 8. Okay. K square a square b L 3 by 2. Clear? Okay, anyhow, this is the equation number 5. Already I wrote the equation number 1. Okay, I wrote the equation number 1. Anybody remember the equation number 1? That is equation number 1. That is rate is equal to k a square b L 3 by 2. This is equation number 1. On comparing equation 1 and 5. On comparing equation 1 and 5, what can you say? What is the change here? On comparing equation 1 and 5, what's the change here? Now rate is increase or decrease or reduce. Okay. On comparing equation 1 and equation 5 and compare equation. So we can written as rate is reduced to 8 by 9 times. Okay. Rate is reduced to 8 by 9 times. This is the question number 10 solved problem. Okay. Question number 10. Don't forget that. Question number 10 solved problem. Okay. Now it is solved problem. Okay. Please all of you take down this question. Next. We have no time. Make it fast. Okay. Next about question number 11. What is about the question number 11? Question number 11. The rate of formation of a dimer in second in the second order is 7.5 into 10 raised to minus 3 more liter inverse second inverse. At 0.05 mole liter minus 1 monomer concentration. Calculate rate constant. We shall calculate the rate constant of this question. Okay. Question number 11. So, let me consider, first of all, it should be consider the given. Let us consider question number 11. Question number 11. Page number 230. 230. First volume. First volume. Okay. Page number 230. Okay. You should write the data. Okay. Let us consider the dimerization. Dimerization of a monomer. 2m gives m2. That's it. Okay. Then rate is equal to K into Vm n. Okay. Then what are the given? Given n is equal to, what's the value of n? N is equal to 2 and m. Okay. That is equal to 0.05 mole liter inverse. Then rate is equal to 7 as per the question, 7.5 into 10 raised to minus 3 mole liter inverse second inverse. Okay. Then formula rate, it should be find out the K. K is equal to rate by m power n. Okay. So we shall substitute this one. What's the given answer? Okay. We should be find out the K. So K is equal to 7.5 into 10 raised to minus 3 divided by 0.052. M value 0.05 10 raised to 2. That is equal to 7.5 into 10 raised to minus 3 divided by the square. Near squaring we get 0.0025. Okay, 0.05 and squaring we get 0.0025. That is equal to 7.5 into 10 raised to minus 3. Okay, 10 raised to minus 3 divided by 0.0025. So we should be multiplied. Okay, the same number, that is, it can be into 10 raised 10 into 10 into 10 into 10. Decimal. Okay, decimal number having. So 4 times you are multiplied by 10. Down also like that. Below also 10 into 10 into 10 into 10. Okay. So you can written as 7.5 into 10 raised to minus 3 into we shall be into here 10 into 10 into 10 into 10. So when you are multiplying by 10, so by again 10, again 10, again 10, we get out of 25. Okay. So easily it can be cut here. Here I means 5, 10. Also Okay, 2. Now you can be substitute this one. Is equal to 7.5 into 10 raised to minus 3 into 2 into 2 into 10 into 10. Am I right? 2 into 2 into 10 into 10. Okay. Here also divided by again having 5. Cancelling. Okay. So value 5 cancelling, then only you get by dividing. Okay. That is equal to we get the total value 30 into 10 raised to minus 3 into 10 to the power minus 2. We get the value like that. 30 into 10 raised to minus 1 is can be written as 30 by 10. 30 by 10. So what's the answer? That's equal to 3 moles inverse liter second inverse. Okay? Please all of you take this question. And next about the 11th question. Book back. Question number 11. Sorry, question number 12. Page number 230, first volume. Page number 230, first volume. Question number 12. Okay. Here for a reaction x plus y plus z, for a reaction x plus y plus z gives product. The rate law is given by rate is equal to k into x power 2 by 3 by 2 and y is equal to y power 1 by 2. What is the overall order of the reaction? We should be write the order, overall order. What is the order of reaction with respect to Z? That's the question. For each term you should be write the formula. What's the formula? Rate is equal to k into x. What is about the x? The power 3 by 2 and y 1 by 2. Okay. Overall order. You should be write the overall order. Three by 2. Here have we what? That x value having 3 by 2. So overall order 3 by 2 plus y value 1 by 2. Okay. So we can written as 3 plus 1, 4 by 2. So what's the value? 2 is the answer. So the second order reaction, that is here 2 means that is what? Second order reaction. Okay. Since the rate expression does not contain the concentration of Z, so the reaction is zero order with respect to Z. Okay. Since, you write that one, since the rate expression does not contain the concentration of Z. Okay. Since the rate expression does not contain the concentration of Z. Okay. The reaction is zero order with respect to Z. Okay. So, okay. So today, up to we finished question number 3 to 12 we have completed. So assignment. Book back question. Book back question. We can rewrite the question number 6. Okay. This is assignment. Okay, please all of you write the assignment. Thank you all of you. Thank you. Have a nice day.